This conference will now be recorded.
Okay, so we understand about array list versus array. Okay, and we started with array list, adding the elements, right? Let's understand more about this array list, also linked list. Then after, let's see an example of vector, and we'll understand about iterables, iterators. Okay, this is the plan for today. Let's see. Let me write new Java file. Linked list. Okay, so now let's understand these properties in terms of linked list. Okay, so how linked list behaves. How linked list behaves. So how to create linked list object? First thing, so you can do the same way. List is the interface. List is the interface, and linked list is the implemented class. Linked list is the implemented class. Just use this Java util.list. Okay, so you have to ensure while importing, you have to ensure you are importing the proper one. So the same collections might be exist in something else also. When you are working in a project, we might use other libraries as well, other jar files, maybe Apache utils or so something else. So we might be using different kind of utilities. So where you may see the list is available in multiple places, and in such cases you have to ensure that you are importing a proper list what actually you are working with. Okay, so these are from java.util package. List is equal to new linked list. Now can I add the elements using add method? Of course I can do that. Okay, I can do that. So I can add an element to the linked list. I can add an element to the linked list. So if you observe this add method, where it is from? So can you see add of element? This is the method that we are using. But if you look at this method is from what? List.last. So we are using a list methods either in array list or in linked list. Okay, this add method is also okay referring to what? List.last file. Okay, so we already know about this. Okay, but let me repeat it. So list is the interface. List is the interface, and this is implemented by interface is implemented by classes. Okay, different classes. So now we understand about array list, and now we're discussing about linked list. So these two classes, these two are the classes. Okay, so this is what a class, and linked list is a class. So you have to be very clear what is interface, what is class. That's why I'm keep writing this. Okay, so this guy is implementing list interface, and of course even linked list also implementing this list interface. Correct? So implements array list and linked list. So what are the methods available in the list interface? Okay, what are the methods declared in the list interface? So all the methods will be implemented as part of this array list and a linked list, of course. Okay, so that is where, like here, if you go to the array list class, okay, array list class, and you can see add method, add of e, where it is implemented. Okay, but in the list, so it doesn't implement. It's because it is an interface, and you can see only declaration. Okay, and while working here, so if you click on it, it takes you to the method in the static way. So what is the reference of what is the reference here? L is the reference. Okay, L is the reference, and this L. Okay, so this L, if you click on this add on and reference L, it takes you to the interface, because because you are looking at the reference. Okay, but if you take okay, if you take array list here directly, okay, so array list L equal new array list. Now if you click on this, it will go takes you to the array list method implementation directly, but still this is not recommendable way of doing it. So always you take interface and the implemented class. However, at the execution time, at the runtime, even though now if I click on this, it's taking you to the interface, but at the runtime, at the execution time, it is going to execute the implementation method. It is going to implement, it is going to execute the implemented method. It's going to execute the implemented method. What happened? Okay, can you hear me? Can you hear me? Hello. Yeah. So hope you can hear me. Okay. So list dot add. Yeah. So at the execution time, it will execute the uh, method from the underlying object. What is the underlying object? Array list. So this is going to the add method of the array list is going to execute at the execution time, right? Okay. So why this approach is recommendable? So if tomorrow, if you wanted to replace this array list with the linked list, if you want, you can replace it, but still you don't have to change this piece of code. You don't have to change this piece of code, because list is the super interface in general. When we are exposing methods or services to the third party, okay, so we give them in terms of interfaces. Then they don't worry about the implementation. Okay, but so as part of our implementation, tomorrow if I wanted to change my logic from array list to linked list or something else, I can modify it. But the end user doesn't affect. The end user in the sense who is consuming our service, Okay, I'll give you one example. This is a little important, that's what I am taking time. Okay, so let me show you one example. For example, I have a method over here. Okay, public void. Okay, let me mark it as a static for now. Static void. Okay, some utility method, some method m or method. Okay, so this is what my method. So here, if I give array list and let's equal, and I'm going to do something here inside. Okay, so I'll have some logic over here. I'll have some logic over here. Now I'm calling this method me method. So this method expects what? This method expects what? This method is going to expecting to send a parameter of array list object or not. So can I send this ll object to this? No, I cannot send, because that is expecting array list, but you are sending a link. You are sending uh, uh, a list object, which is a super type. Okay, so this is not acceptable. What you have to send is, you'll have to send array list object only. You have to send array list object only. Now it's fine. You cannot, other than array list, you cannot send anything. You cannot make use of anything else. But if the method is a list type, the method is a list type, you can pass array list, you can pass linked list, you can pass vector or whatever, so whatever you want. So that is what, when we are giving API, we'll declare the interfaces and expose it. Okay, so the users are going to send the objects whatever they want. Anyhow, we'll be handling the logic internally here. Okay, so here the logic also, like whatever. So while returning also, the return type also, in general, we should be always returning the super interfaces. We have something. So inside this, I can make use of any implemented classes of list, but ultimately I'll be returning the list. Okay, so the point here is always recommendable to use the super type and child object. Super type and child object. Okay. Now, so ll dot add of 100. Now come back to the linked list properties. Okay, duplicate elements are allowed or not in linked list. Okay, by adding one more 100, I can check it out. So I can check this. So is it accepting or not duplicate elements? Okay, no error, but at runtime, at the execution time, is it going to give me any issue? Run this. The console, where is my console? Okay, I did not print anything, so I don't see anything in the console. So let me print this. Okay, I'm printing the linked list. You can say 100. So happily it accepts duplicates. Add up. Then insertion order is preserved, of course. Let me add a 10. Let me add 3. Again a bigger number. L dot add of 20. So I have added the numbers in a zigzag manner. So if you run this, are we going to get the same order? Are we going to get in the same order? 100, 10, 3, 20. Yes. Whatever the order I have inserted, I can see the same order. So meaning that insertion order is preserved in linked list. Insertion order is preserved in linked list. So is it going to allow heterogeneous elements? Meaning that, like, I wanted to add true, I wanted to add some 10.5. Yes, of course, it is going to allow heterogeneous objects. Okay, linked list allows heterogeneous objects, and by default, null insertion is allowed or not. Okay, so add of null. Is it accepting or not? Is it accepting or not? Of course, it accepts. Okay, see here. So whatever we have with respect to array list, you can see that exactly the same thing in linked list, right? No difference with respect to these characteristics. Then why do we have two things, either linked list or array list? One of them is enough, right? Why there are two things? So that is where you will have to understand the differences. You will have to understand the differences of array list and linked list. Okay, so the underlying data structure, okay, the underlying data structure for array list, the underlying data structure for array list is global array. Let me add that. Underlying data structure is global array. Then what is the underlying data structure for this? I mean, on what basis this linked list is implemented is, okay, underlying data structure for this, for linked list is double linked list. Okay, double linked list. So we have a concept of linked list, single linked list, double linked list in data structures. Okay, so this is used double linked list data structure for implementing this. Okay, Java util linked list, okay, is implemented by using double linked list data structure. Okay, what are the advantages that we are going to get with respect to this double linked list? Okay, so you must be aware of that. Okay, about the data structures. Hoping that, if not, so let me try to keep it. So here, double linked list, you will be having elements, okay, with three sections in case of double linked list. Okay, in case of double linked list, you have three sections. Why three sections? So you will have an element here, okay, 100. You have element 10. You have element of 3. These are your elements. Okay, and what about these other cells? So these are going to maintain the addresses. The other two cells are going to maintain the addresses. So what are the addresses it is going to store? So it is going to store the address of previous, okay, previous element address. And here this is going to store the next element address, the next element address, next element address. So previous element address and next element address, previous element address and next element address. Because in case of linked list, so how the elements are going to store in the memory is not in a contiguous memory locations, not in a sequence. Okay, not in a sequence. Wherever it has enough space for single element, yeah, it's going to set over there. Okay, so in case of array or array list, okay, the elements are going to store in a sequence. Okay, the elements are going to store in a sequence. So like this, all your elements will be stored in a contiguous memory locations. Okay, in a contiguous memory locations, it stores like this in a sequence. In case of array or array list, why array list also? Because array list underlying data structure is again an array. What is that? Global array. So these are like memory locations in contiguous memory locations, contiguous memory locations. But linked list is not like that. One element can be stored at one location, the next element can be stored in separate location. Okay, but how are all these are going to link all together is by using of these addresses locations. What is the previous element of for this, what is the next element for this? So that is where it is going to capture, so and link all together. Okay, so these are going to link. So this element can be one place and this element can be a different place, but ultimately they are going to link together. They are going to link together. Okay, so they'll establish a link. So all are connected, but not in a contiguous memory location, different locations. Okay, how they are in linked is they are going to capture the addresses. Okay, and each element, this combination is known as a node. Okay, we call it as a node. It's a terminology. This is one node and this another node. So we call it as nodes. 3 elements I have, meaning that I have 3 nodes. I have 3 nodes. Okay, all right. So now adding the elements. So both are using the same method, add method of list interface. But if you look at the implementation part, okay, if you look at the implementation part, okay, in the array list, go to array list class. So here an add method. What is happening here? So it is just incrementing the size of the array, okay, and then just it is adding that element in the next index. That's it. If you look at this is an array of size plus plus whatever the size it has already. Okay, so okay, so for example, already you have an array of 10 elements. Okay, you have 10 elements, you are adding the next element. Okay, you are adding a next element, 11th element. So it is ensuring that capacity, it allows that, okay, if it has this capacity of adding another element or not. If it doesn't have the capacity, then it is going to increment its capacity. And after that, so it just doing that array of size plus plus 10 plus 1 11. So array of 11 equal to element. They are simply adding it. The simple implementation, adding one extra element into the array. Okay, that's what happening in case of array list. But if you look at linked list, implementation, okay, go to the linked list class, go to add method. So this is what calling linked list of e method, one more method. And what is happening here? Link e as last element. So by default, this is going to add the element at last. Okay, at the end of the linked list. So here there is a concept of node. So the node is a last node. Okay, creating a new node of this one. You can see the previous okay, this is the last element and null. This is the node is a combination of 3 things. Okay, so here previous element, okay, next element and the current element. Okay, so here you can see the implementation of item next previous. So node is a static inner class. So this is where an example of inner classes you can understand, but anyhow we'll discuss during the inner classes. Okay, if you remember when we are discussing about the static, I have given some introduction around this. Okay, so node is a static class which is part of linked list, so we call it as inner class. Okay, inner class. When you write inner class, okay, so there are different kind of inner classes. One of them is static inner class. Okay, so what it is doing is just creating, it has a constructor and initializing element next and previous. Okay, if you understand this implementation, so here if the list is null, L is null, then so the new node is assigning to it first, otherwise so it is going to add to the next element. Okay, incrementing the count. So the logic is straightforward, just adding the node to the existing list as a last element, last node. Okay, so and it has to ensure the first node and last node, it has to keep it. If you look at last node, they're just passing null, meaning that there are no more next elements for this, because this is going to be a last element. As it is a last element, there will not be no next element, so null. Okay, and previous element, so they're whatever the already last node, right, that they're making it as a previous one, and this current element is going to become as the current node, the last node. Okay, that's what the simple logic here. Okay, so go back and see those. So linked list. Okay, this is how it handles. Then what is the advantage? Still we are not concluded that point. What is the advantage of it? So the advantage of it is, okay, if you wanted to add an element, or insert an element in between, suppose I wanted to insert an element here, I wanted to insert an element here in the array list. Okay, then what I have to do? Okay, what I have to do, I'll have to swap all these elements or not. So it's going to create one more cell over here, okay, because I'm going to insert one more thing. Okay, then what will happen? So this guy has to move, this guy has to move to here, yes or no? Okay, swap operations, right? So it has to move, then this guy has to move to this guy. So all swap operations, yes or no? Yes or no? So this fellow has to move to this guy, right? So swap operations, we will have to perform swap operations from here to here, the next element, whatever new element. Now this cell is going to become empty, so I have a space. Just imagine a row of chairs where all the people are sitting, and just imagine that there is one more person is coming in and he wanted to sit in between. Then everybody has to move and like keep the middle seat become vacant, right? Then he can sit. In the same process here also, as this is contiguous memory locations, if we want to insert an element in between, so it requires more swap operations that takes extra time. And the same thing happens for deletion also. If one element I wanted to remove from here, again it has to readjust, it has to readjust. That is what then one challenge here in case of arrays. Challenge in the sense it takes time. Okay, but if you compare the node, right? If you compare the linked list, right? So this becomes more simpler than this. If you wanted to insert, if you wanted to mark one more element here, okay, if you wanted to insert one more element next to 100, okay, so you have an element of 101, you have an element of 101 and I wanted to insert that. So here number 101. Now what I do is, okay, what I do is I want, so after what is the next element of 100, so I wanted earlier, this is what the next element of this. So imagine that, so you have address locations of this one is 1000. So for example, just I'm giving 1000, this is 1020, this is 1030, the memory locations of these elements. Okay, now here if you observe here in this 100, what is the next address element initially it will be having is 1020. So this is going to have 1020, it stores 1020, meaning that what is the next element, this is the next element. And imagine that this has a memory address of 1040. Okay, now I wanted to insert this, I wanted to insert this element next to this 100. Then what I'll have to do is, so it is just enough to update the memory address. That's all, I don't change anything. I just need to update this address location. Instead of 120, what I'm going to do is 100, what I'm going to do is, okay, 140. I'll just add this 140. Now the next element becomes what, 101. Okay, and if you come to here 101, what is the previous element for 101? So this I'm going to update the memory address of 100. What is the memory address location of 100,000? So I'll add that. And what is the next element for this? The next element will be 10. So here the memory address will be updated to 120. So now what is the previous element for 101? 1000 location. 1000 location, what I have? 100. What is the next element of 101? So address location is 1020. It goes there 1020 and the element is 10. That is how now the links are broken here. Okay, so now it is going to, okay, it is going to link to this. Okay, and this guy is linked to this guy. Okay, do you understand? Any questions? This is how either insertion or a deletion, whatever. A deletion is also like just updating the previous and next elements addresses. That's all. So no more swappings are required. So that is where the point here is. If your frequent requirement is, okay, requirement is insertion or a deletion, then prefer linked list, then prefer linked list. Okay, if your frequent operation is retrieval, then use array list, because this is more faster, because these are contiguous memory locations, right? Just to access next, that's all. So there is no need of checking the next address, and further logic is not required. Okay, so this is more faster than linked list for accessing the elements. Okay, uh, okay, so go back here and get into the linked list. So linked list. So linked list is extended word abstract sequential list. Is implementing a list, dequeue, clonable, and serializable. Okay, but if you look at the array list, so this is implementing random access. Okay, this is implementing a random access interface, which gives faster access to random access. Okay, array list is implementing what? Random access interface. So this improves the uh, this improves the performance, and it ensures it returns the elements, any element with the same time, constant time. It takes the constant time to access the element. Okay, any element of your array list. That's what you will have to use array list. You will have to use array list if your frequent operation is accessing it, retrieving it. But if your frequent operation is either insertion or deletion or adding element in the first or last, so prefer okay linked list. All right. So if you observe in the linked list, you will find extra methods also. Add first, add last, add first, add last. You don't see these methods in case of array list. These are specific methods of linked list. These are not overriding methods. Okay, this is specific to linked list. But if you look at add method, this is the method just overriding it. This is from the parent, like so list class. This is a list class method implementation. But the other one is linked list specific methods. Okay, so you can just give control O outline to see all the available methods of it, and you can just practice. Okay, you can see get first, get last, remove first, remove last, add first, add last. Okay, contains, size, remove, add all to add other collections to the linked list, clear to clear everything, get so to you if you want to access any element, set if you want to update something, add if you want to add, remove based on the index. So again, these are like again few more methods, extra methods recently added based on the indexes. So we have node, you have last index of, because you have an object and you wanted to know the index position. So pick, element, poll, remove, poll set. So many methods are there. So it's all about the requirement, what is your based on your requirement. So you just go there and refer the specific method of the requirement and use it. That's all. You don't have to buy hard, or you don't have to remember these many things. Okay, depends on the requirement. So look at the API and use the respective method. Okay, so again, constructors, if you look at the constructors of the linked list, you have constructor, linked list of uh, collection, which takes array or set or something, any other collection. Okay, it accepts. You can understand here also. So it is, they are giving collection, not either a array list or something else. Collection, and collection is the root interface. From there we have list interface and set interface, meaning that you can pass a collection, any collection implemented object, meaning that you can pass array list, you can pass hash set, anything, you can pass vector, anything it will accept. If you give only here array list, linked list of array list, it accepts only array list. but I wanted to accept anything, any kind of collection. So that's where you are giving collection in the method. Okay. Yeah, linked list constructors, you have two constructors. Okay, so that is what about okay, linked list. Okay, so then I recommend you always refer the source code. That is the best way to become a good programmer. So look at the existing source code, Java source code, because Java is the source code is in Java only, so you will be able to understand. Okay. Understand, look, by looking at the source code, you can improve the code readability skill, meaning that's what you can understand the existing code. So that's how more important. When you join a company or a project, so there will be existing code already. You will have to understand that to implement your logic, your requirement. Okay, that's most important. So by going through this, you can start practicing understanding the existing code, and by looking at, you will be knowing this the coding practice also. So see here, before using your element something, you'll have to check nulls, you'll have to use null check, some kind of tips, programming tips you'll understand. Okay, so that's what code reading the code is more important. Okay, reading the code, reading the existing code is the best habit. Okay, so let's start. All right, array list and linked list, we have seen both of them, and we have something else called vector. Vector we don't use in general. Okay, it's a legacy class. Okay, legacy class use array list. 90% of the cases we use, and the cases of the cases linked list. And don't, there is 10% of C is being used. Okay, but any can I translate as what I have? Do the same thing as I have done for array list and linked list the similar way. Can I do this? Let's start giving error. So add gas to list. Why? Because bar. This is blender. Okay. Vector example. Let me refactor. Do you understand the problem? So I have given my class name is also vector, which is same as predefined class vector. So should not be giving that. Okay. Vector example. Now, yeah. So this vector I wanted to import from the util. Okay. So java.util.list. Java.util.vector. Okay. Vector is a legacy class, meaning that vector is introduced in JDK 1.0. Okay, 1.0, whereas list is introduced in 1.2. But still, so you can see this vector is implemented by list. Okay, this modifications to the vector. If you go to vector class, okay, vector, so this is introduced in JDK 1.0, and this is extended by abstract list and implementing list interface and random access interface, clonable interface, serializable interface. If you observe the array list, this is also implementing the same stuff. No difference. Do you see any difference between these two? Extending abstract list implements list, random access, clonable, serializable. If you look at this one, it is extending abstract list, implementing random access, clonable, serializable. Come on, then what is the difference? What is the difference? You can add the elements, the same elements. You can add the duplicate elements. You can add the null, everything. Okay. Then what is the difference? So let's look at the methods. Add method. So adding the element. If you look at the code also same. You see, add method logic is same as your ArrayList add method. Then what is the difference that you see here is synchronized. Okay, synchronized. What is the difference that you can see here is synchronized. And if you want, you can just look at the other methods. Okay, most of the methods. Add, insert, element, remove. Okay, remove. If you look at remove method, what is that? Synchronized. Okay, synchronized. So the point here is the vector is the best fit. The use is okay. So in multi-threaded environment, so multi-threading. If you are writing multi-threading applications, okay, so if mostly like a gaming, so maybe like a gaming or server programming, okay, server development, basically Tomcat, WebLogic, this server implementations. So in multi-threaded applications where we write multiple threads and sharing data across these multiple threads, that is where the data to be synchronized, the data to be consistent when multiple threads are accessing the same object at the same time. There is a data inconsistent issues, that is where, so we will have to be very careful. Okay, so what collection of data should use? Okay, so in case of multi-threaded environment, the best fit is vector. So that's what it's uses of multi-threading environments, like working with you in our regular web applications is uh, not so frequent. Okay, not so frequent. That is what vector usage of the vector you see like very rarely. Okay, so in only in multi-threaded environment is recommendable, the vector is recommendable to use. Okay, so everything else is same. You can add the elements, you can add the duplicate elements, you can add the duplicate elements. Okay, so you can add null. What else? You can add 3. So just print this. This is a vector. Okay, so Delos, the same properties, you can do the same thing. Okay, okay, so vector and array list are same. Only the difference is all the methods of the vector are synchronized. So in multi-threaded environment, the vector is best fit. And out of it, array list is the best fit. Linked list is if your frequent operation is either insertion or deletion. Okay, then linked list is better. Okay, so here if you see the underlying data structure for okay, the underlying data structure is doubly linked list. Duplicate objects are allowed, insertion order is preserved, heterogeneous objects are allowed, null insertion is possible. So it is implementing list, queue, serializable, clonable, and all this stuff. Okay, these are the methods. We have seen constructors. Everything is documented clearly, so you can just refer to that. And the interview question may be vector and array list differences. Okay, in vectors all the methods are synchronized. Okay, in array list not synchronized. Okay, so as multiple threads in the multi-threaded environment, as all the methods are synchronized, this is thread safe, but this is not. Okay, so it's one thread can access at a time when it is a synchronized method, so performance is low. But here we can access like anything by multiple threads, so performance is high. So vector is introduced in 1.0, this is introduced in 1.2. That's what the difference is. Okay, anyhow I have given the clear documentation here, so just refer to that. You will understand still better more. Okay, the next thing is cursors available in collections. That's what iterators. Okay, we have these three iterators: enumeration iterator, list iterator. We'll see this in the next session. Okay, we'll speak about this in the next session.